Hey guys, good morning. Welcome back to school. Today is Monday, the 30th of March, and we're going to start with our notes today. So we're starting section 9.5, and it's called, a word you guys know, tangents. Tangents. It is like trig, but it's the same word, but it doesn't mean the same thing in this case. You'll see what I mean. So let's go ahead and do some vocab. We have the word tangent, or as I like to call it, a tangent line. So we'll put line in parentheses, because I like to say tangent line, but some people just say tangent. Okay, a tangent line is a line in the same plane as a circle and intersects the circle at exactly 1 point. One point, and that point is called the point of tangency. Okay, that's another vocab, so I'll highlight that. Point of tangency. Okay, so we have a circle here, and here's the center. We have a tangent line. Let me use my thing here. Just a good old tangent line. It is a line that crosses at 1 point. So let me just write this. Here's our tangent line. And this point right here, the green one, would be called the point of tangency. Point of tangency. Okay, so there's our tangent line. Another vocab word, common tangent. Common tangent. This is a line, ray, or segment that is tangent to two or more circles. Okay, so another drawing. We have a small circle and a bigger circle. Oops. All right, and our question is like, how many common tangents do these two circles have, if any? Oh my word. Okay, so let's see how many lines these have in common. Remember, it has to touch both circles at only 1 point. Well, that didn't really work. Maybe I can just draw it myself. So it touches the first one, and it touches the second one. Just once. Okay, is there another place where it can touch both lines, or both circles? Right here. Okay, so these two circles have two common tangents. It's just where it touches two circles at the same time there. We have two little things to say down here, because the tangent line, or you can say tan line, touches at only 1 point the diameter / radius is perpendicular. I'm going to say perp here and draw my perpendicular sign to the tan line. because the tan line touches at only one point, the diameter or radius is perpendicular to the tangent line. So go back up to your first drawing we made here. Okay, this would be my radius. Let's do it in blue. Here's my radius. Okay, you see how that line is perpendicular to the tangent line? When something's perpendicular, it makes a right angle. So put your little right angle box in there. Okay, it makes a right angle. And one more thing, and then we have a couple examples. If two segments from the same exterior, it's going to be on the outside of the circle, exterior point are tangent to a circle, then they are congruent. And I'm just going to put the congruent symbol. Okay, what does that mean? Here we have a circle. Okay, say this is the exterior point right here. If there are two lines that are tangent to the circle and go to that point, then they are going to be congruent. Okay, and that's all the notes. We have 4 examples. Okay, so example number 1. We have a circle. And we have the radius. Here's the center, K. The radius, KL. And we have a tangent line. And this is point M. Okay. And we have another line that forms a triangle. Now, what did I say about the radius and the tangent line? They make a right angle. So what kind of triangle is this? It is a right triangle. KM is 29. The radius, KL, is 20. And the tangent line, LM, is 21. The question is LM for sure tangent? Does it definitely make a right angle? Let's see. How can we check that? Well, let's make sure the Pythagorean theorem is true, because if the Pythagorean theorem holds true, then that means this is, in fact, a right triangle. Because remember, the Pythagorean only works for right triangles. So let's say 21 squared plus 20 squared equals 29 squared. And let's figure it out. 21 squared plus 20 squared is 841, and 29 squared is 841. So it does work. Check mark and yes. Again, just to recap, the way we can find out if something is tangent for sure is by using the Pythagorean theorem, because the Pythagorean theorem only works for right triangles, and if it holds true, then that means this is a right triangle. So example 2 is kind of similar to this. We have another triangle. We have the radius CB. We have the tangent here. This is point A. And then it makes a triangle. The radius is 8, so CB is 8. This is point D, and DC is another radius, so that's 8 as well. From D to A is 9, and the tangent line is X. So if AB is tangent to the circle C, then we need to find X. Okay, so like we said, we use the Pythagorean theorem. We have BC, which is 8 squared, plus X squared equals the hypotenuse. The hypotenuse is 8 plus 9, which is 17 squared. 8 squared is 64. 17 squared is 289. Want to get this x squared by itself, we subtract. X squared is 225. Take the square root. Square root of 225 is 15. So, come back up here. X equals 15. These aren't too bad, right? Pretty easy so far. Number 3, and we have one more after 3, and then we're done. Okay, here I have a circle, and we have 2 tangent lines to this exterior point C. We have AC, and we have BC. And our circle is circle Z. Remember, circle is always named by the center. So AC and BC are tangents. Oops, AC and BC are tangents. We want to find x, and x is, we have 3x plus 2 and 4x minus 3. So remember that I said if 2 tangent lines meet at an exterior point, they are congruent. So all we do, 4x minus 3 equals 3x plus 2. If you solve for x there, we can add our 3, which is 4x equals 3x plus 5, and then subtract 3x, we get 1x, or just x is 5. That's it. These are super easy. We have number 4. Maybe I spoke too soon. Number 4 is a little challenging, but if you stay with me, it's not, I don't think it's that bad. Okay, so here we have circle T. Circle T has 3 tangent lines. One this way. Let's see if I can draw this. Okay, I already messed up. One this way. One this way. And then this one goes like this. It makes a triangle. A little bit too far. Boop, 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 boop. Okay. So there's our drawing. This is point Q. This is point R. This is point S. And then our points of tangency. We have N up here, we have L over there, and M right there. Okay, so triangle QRS is, what's it called when a polygon is on the outside of a circle? Circumscribed. It's circumscribed around T. They want us to find, oh, I should probably give you measures first. This is 2. This is 2. This is Y. This is 6. This is 10. And this is X. Oops, I'm going to do that in green. Okay. They want us to find X and Y and the perimeter of the triangle. Okay, give you a second to copy that down. Okay, so up here, we said if 2 tangents meet at an exterior point, right here, then they're congruent. Here we can see, let's just look at Q. Let's just look at point Q. Here from N to Q, and then from L to Q, those are both 2, right? Because they're congruent. So let's look at point R. If MR is 6, then LR would also be 6. In the same way, we have point S. From N to S is 10. So from M to S also has to be 10. So we have X is 10, Y is 6. Let's find the perimeter of this thing. We can do that by just adding up all the sides together. So we have 2 plus 2 plus 6 plus 6 plus 10 plus 10. The perimeter is going to be 36. And it doesn't give us any units, so we just say 36. And that is it. I'm going to give you some work tomorrow, but if you would like to do some more practice problems, if you want to, these are totally optional. Practice problems in your book on page 681 and 682. If you would like to try 1 through 8, you totally can, but again, this is optional. I'll give you some more book work tomorrow. That is all of the notes. I miss you guys. Keep looking at Schoology for updates, and